Okay, so I'm going to look at question 8 a little bit differently here. Question 8 gives us two circles, and it tells us graphs often use pictures to explain trends. The circles to the right are used to show CD sales of a certain singing group doubled from March to June. Measure the diameter of the circles in millimeters and calculate the areas. Okay, so I was trying to figure out a way that I could measure this on screen, but I don't really right now have the capabilities to do that without my camera. So I'm going to kind of draw it out here. If I'm thinking about measuring the diameter, I would have wanted to take my ruler, my angle ruler that you have from class, and measure the diameter in millimeters. So from here all the way across to here. If you do that for the March circles, you get a diameter of 8 millimeters. Okay, so when I'm calculating the area of these March circles, I'm going to use area equals pi r squared. Since the diameter is 8 millimeters, we know the radius has to be half of that. So what our calculation ends up being for March, area equals pi times 4 squared, which would give us 16 pi millimeters squared for March. Okay. When I go over to June, I notice that if I measure from here down to here with my angle ruler in millimeters, okay, I do get 16 millimeters. And that means our diameter did double. Okay. But what the question is saying is that our eye doesn't really respond to the diameter. When we're looking at this, we're thinking about the space taken up by these circles. And that's not diameter, that's area. Okay. So what the question is asking us is, did doubling the diameter really convey to the person who's reading this graph that CD sales doubled? Okay. Remember, our eye catches the area, not the diameter. So over here, we had 16 pi millimeters squared for area. Let's think about this one. If the diameter is 16 millimeters, the radius is 8. So we have area equals pi times 8 squared millimeters. So we have 64 pi millimeters squared. We compare 64 pi to 16 pi, and that's not doubled, okay? That's actually quadrupled, okay? So what that means is that no, okay, this is not an accurate representation. It is deceiving because even though we have double the diameter, we have 4 times the area in a circle like that. So it is deceiving, and it's not an accurate description of that graph. Okay, our last question that we looked at, okay, was question number 10. And again, I want to pull those graphs up. Okay, your question number 10 and my question number 10 are not the same. Interesting. Let me pull up your question number 10 appears to be a triangle. That's my question 11. I've already noticed also there was a difference in the instructor's edition and the student edition in the very first question we went over, which was 3. So let me take a second and pull up my instructor's edition and kind of show you what I saw here. I'll have to go back up. This is my question number 10. Okay, so if you answered question number 10 in the triangle, I apologize. That's an error that was made in whoever created the course pack, so I'll have to go back and fix it. Nonetheless, while we're here, and you can see this question, take a look at question 10. Okay, we have 2 graphs here. We have graph A and we have graph B. And one of these graphs shows how many pets each of the students in a class of 29 children has. And the other graph shows how many times in a month each student in the class brings lunch to school instead of eating in the cafeteria. Okay, so which one do you think is which and why? And there's no labels. We don't know that. I see that I've got down here 29 individuals, and when I'm looking at these graphs, it's one of these is either telling me how many pets they have or how many times in a month they bring lunch to school instead of eating food served in the cafeteria. So what do you think? Okay. For me, my first glance is probably going to tell me that the graphs are scaled the same way. This one does go up a little higher than what we have other places. Okay. I also see, a different amount of results here. So what do we think? What do we think in terms of which one would be counting pets and which one would be counting numbers of times that we bring lunch to school? Okay. If I look at these, I'm probably going to be more inclined to say that this is the graph that counts pets. Why? Overall, the students have a shorter number of responses. Maybe you have, I don't know, a bunch of ants or something, or you live on a farm and you have a whole bunch of pets. Maybe that's this person. But as you can see, these results are consistently higher. Okay. I would expect that it's more likely a student brings lunch to school a lot of times than it is more likely that we see numbers like 10 pets and 6 pets and 7 pets. I think this is more likely a pet graph. Again, we don't have any labels, so we don't know for sure, but we just have to think about what is more likely based on the information that we have.